Alright guys, so today we're going to cover double angle and half angle identities. This is section 4.4, where the homework problems will be coming from. And you'll want to identify the double angle identities and the half angle identities on your formula sheet. I'm not going to require you to memorize those identities for tests, so you'll have access to those. Yes, Karen?
Those, like, sum and difference identities that we just used, do we only use them for what we just did, or are we going to use them in, like, the identity things?
Yeah, no, we won't use them in when you're proving identities. We won't use those.
Just for what we
Yeah.
just did.
Well, what we just did, and then some other specific examples that you can see in that video from section 4.3.
Angles.
Like sine of 75 degrees is 45 plus 30. Sine of 45 plus 30, and then you use that identity and those exact values to get exact values. And today we're going to be doing some of the same stuff with the double angle and half angle identities as well. So let's just dive in and have a look at an identity. Now this one is an actual identity. Just verify that the sine of 2x is equal to 2 tan x over 1 plus the tangent squared. Now what does your first instinct tell you to do if you're trying to verify sine of 2x equals 2 tan x plus over 1 plus tan squared? Change tangent to what? Sine over cosine. So if we write everything in terms of sines and cosines, that's usually a good strategy. So if we wrote that in terms of sines and cosines, we would have 2 times sine x over cosine x. And all of that is over 1 plus sine squared over cosine squared. Okay, so now we have complex fractions, fractions within fractions. What can we do to get rid of those fractions? We need to multiply top and bottom by a common denominator, right? What is the common denominator between cosine x and cosine squared x? Cosine squared x is what we need to multiply top and bottom by. So multiply both top and bottom by cosine squared of x. And we got to remember that when we multiply the bottom of this fraction by cosine squared x, you have to distribute it, right? So, and remember too that that's cosine squared x over 1. If you wanted to write it as another complex fraction, that just kind of makes it clear where things are. All right, so when we multiply the top by cosine squared x, what do we end up with? One of the cosines cancels, right? Because that's cosine squared x. Let me write this. I think I prefer to write this as so if I'm multiplying top and bottom by cosine squared x, that would give us this. And if we multiply this by cosine squared x, that gives us this. So that's kind of what we're multiplying by 1. Right? So one of the cosines will cancel with that cosine in the bottom. Cosine squared is cosine times cosine. So one of those will cancel, and in the top I will be left with 2 sine x cosine x. Because this will cancel with one of these, and we're just going to be left with 2 sine x cosine x. In the bottom, when we distribute, cosine squared of x times 1 is cosine squared x. When we multiply it times the second term, the cosine squareds cancel, and we're just left with sine squared x. And bells should be ringing on that. What's cosine squared x plus sine squared x? That's equal to 1. So this is just 2 sine x cosine x, which is indeed, that's our double angle identity. That's equal to the sine of 2x. Now that's a simple identity that we could use, and you'll have a couple of those to practice for homework. But I don't think I'm going to test you on the double angle identities in the context of proving identities or verifying identities. Okay? Any questions on that before we move?
How did you get the bottom?
Which bottom?
Cosine squared x.
Okay, when I distribute this cosine squared x times 1, that's where we got the cosine squared x, right? And when you multiply it times this,
Oh, then it.
the cosine squareds cancel and you're just left with sine squared.
Okay.
Do you think maybe in your next class you could record this and put it up so Rachel could watch it when she gets back?
Could you say that again?
Are you recording it?
Yes.
Oh, I didn't know.
That was Emma Roberts, ladies and gentlemen. All right. So, next example. Yeah, I am.
Okay.
It's fun. Now my dumb question will be there forever.
Okay, forever? I don't know.
Forever.
YouTube won't last forever. Find the exact value of the cosine of 2x if the tangent of x is negative 4/3 and x is somewhere between pi over 2 and pi. Okay, cosine of 2x if the tangent of x is negative 4/3 and x is somewhere between pi over 2 and pi. Now, we're going to use one of our cosine of 2x identities from our sheet. And this is one that has 3 different identities. They all come from the first one. Now, which one would you pick and why? Have a look at your identity sheet. Cosine of 2x. Why wouldn't you use the first one, Claire? You were about to say the right thing. It uses 2 quantities, doesn't it?
Yeah.
We'd have to find the cosine and the sine of the value to use the first one.
The first one under what?
Cosine of 2x.
Oh, okay.
This is a double angle. Use the second one or the third one, which only requires us to use the cosine or the sine, but not both. What is the second one? Is it 1 minus 2? So we're going to use cosine of 2x equals 2 cosine, 2 cosine squared minus 1. So to use this identity, I have to know what the cosine of x is. We're going to use the information that they gave us and tell us that the tangent of x is negative 4/3 and pi over 2 is less than x is less than y. What does that information, what does this information right here tell us about x? X is an element of quadrant 2. That's correct. Between 90 degrees and 180 degrees. Pi over 2 and pi. X is in quadrant 2. Okay? Now, because x is in quadrant 2, we can draw our reference triangle. We're told that the tangent of x is negative 4/3. Now, tangent is opposite side over adjacent side, so that's 4 and 3. And which one of those values has to be negative?
3.
The 3 has to be negative. Because left and down is positive, up and right. Excuse me, left and down is negative, up and right is positive. So this is our good friend 3, 4, 5 right triangle. Yeah, it's the easiest one for the Pythagorean identities. So I'm trying to find the exact value of the cosine of 2x. I'm ready, right? Because all I needed to know was the cosine of x. So this is going to be 2 times the cosine of x squared. What's the cosine of x? Cosine is adjacent side. So it's negative 3/5. We're going to square that, right? All right, so that's 2 times 9/25, which is 18 over 25, minus 1, which I'm going to go ahead and write as 25 over 25. And that gives me negative 7 over 25.
Oh, you already did that. Never mind.
2 times 9 is 18.
Yeah, you can find it.
So
Cosine 2x.
the cosine of 2x is negative 7 over 25. All we're doing is using these formulas to find values. Now, Let me ask you a question. Does that answer make sense? How could we determine if the answer makes sense?
Where it is on
The sign kind of, how do we know that's the right sign? How do we trust the formula to give us the right sign here? Because a lot of the formulas have plus or minus in them, this one doesn't. If x is in this interval, from pi over 2 to 2 pi, right, where would 2x be? If I took this and multiplied it through by 2, what would I get? Pi is less than 2x is less than 2 pi. So it's somewhere in the third or fourth quadrant. Do we have some negative cosine values in the third or fourth quadrant? We do. So it's a third quadrant angle in this case. 2x is in the third quadrant. That's where cosine is negative. So I mean, an advanced level question might be, given this information, what quadrant is 2x in? And then you would have, no, I'm not. But then you would have to find this value, and this value would tell you it's in the third or fourth quadrant. And that value would tell you it has to be in the third. Yes, because if they give us x, we're interested in 2x, so you multiply that identity through by 2 to get that. And that's going to be very relevant for solving trig equations. It's going to be relevant as we move forward here too. All right, let's look at the next example. All right, through this, here's the next one. Find the exact value of the tangent of 2x. Excuse me. Example 2.5. If the secant of x is 13 over 12, and there's that funny looking stuff, 3 pi over 2 is less than x is less than 2 pi. That gives us the domain that we're working with in this particular problem. Gives us a value for x. What quadrant is that? 3 pi over 2 is less than x is less than 2 pi is the fourth quadrant. That's between 270 and 360. So x is in the fourth quadrant. We're always going to start with our identity because the identity is going to tell us what we need. What is the tangent of 2x? Identity. 2 tan x? So if they gave us the tangent here, I wouldn't have to draw any triangles or do that. But I have to find the tangent of x to use this identity. I can't use the secant of x directly. The secant of x just gives me some values that I can use to find the other trig function values for angle x, which we are told is in the fourth quadrant. So we're in the fourth quadrant. The secant is the reciprocal of the cosine, so that is the hypotenuse over the adjacent side, so this is 13, and this is 12. Both of those are positive. Hypotenuse is always positive, and right is positive. Down's going to be negative, and this is our other, it's a familiar triangle, right? This should be a 5, 12, 13, so that's negative 5. 12 and 13. And the whole reason that I did that is because I need to know what the tangent of x is to use this identity. And so I have to draw the triangle to find the tangent of x to plug it into this identity. What is the tangent of x? Negative 5 over 12. Is there a plus or minus in this identity, or is it? It's just straight up. So this one, 2, takes care of the sign on its own. So 2 times the tangent of x is negative 5 over 12 over 1 minus the tangent of x squared. Yes, square top and bottom. All right, so that's going to be, you can go ahead and multiply on the top if you'd like. 2 times negative 5/12 is negative 5 over 6. And in the bottom, 1 minus 25 over 144. And we're not going to ever leave complex fractions in our answer. So again, we're going to be multiplying by something to get rid of that complex fraction. All right, multiply top and bottom by what? 144. So multiply. You could if you wanted to. It's going to be easier to do after you get rid of fractions. Well, I say it's easier. Maybe, it's just multiply by 144. Thank you. 6 goes into 144 24 times?
Yeah.
And 24 times negative 5 is, it's what? Do what? 5 times 24 is 120. So negative 120 up top. And in the bottom we'll have 144 minus 25. Just have to remember to distribute. And that gives us negative 120 over 119, which will not simplify. Negative 120 over 119. Good enough? So this, guys, we go back to test 1 material. The basics that we did of finding reference angles and placing these things into quadrants is an extremely important skill, right? So if you can't do that skill of drawing these triangles and put them in the correct quadrant, then you're going to go. All right. Now, this is actually, I think, a little easier than the previous 2 examples. It says find the exact value of the cosine of 165 using half-angle identities. Okay? That's kind of maybe a little bit more help than I would give you. Well, no, I would tell you that, because otherwise you could perhaps use a sum or difference identity to find cosine of 165. So if I want you to use a half-angle identity, what is 165 half of? 165 is half of what? Multiply it by 2 and you get what? 330. So what we're doing here, if I'm using a half-angle identity, the cosine of 165 is equal to 330 degrees over 2. Now, why is 330 degrees useful to us? It's a special angle, right? The reference angle for 330 is 30 degrees, or pi over 6, but 30 degrees because this problem is given to us in degrees. So 330 degrees over 2. Now I need the formula. What's the formula for the cosine of x over 2?
Where's that under?
Half-angle identities.
No,
I don't see that.
it's not. It's a half angle.
Sum of product. Oh, it says half angle power reducing.
Yeah, I don't like the way those are given to you. Power reducing. So you guys don't have the half-angle identities on here. Boo that.
Slash half.
All right. Boo that. There's the formula right there. Cosine of x over 2. I'm going to give you an updated formula sheet that has this one on it.
Cool.
Is equal to plus or minus 1 plus cosine x over 2. Now, you guys, the ones that they gave you there, if you took the square root of both sides, then you would get that, plus or minus. But that's not very useful, in my opinion. Okay, it's more useful like this. All right, so the cosine of 330 over 2 is equal to plus or minus 1 plus the cosine of 330 over 2. So we just make the substitutions now. And we're going to have that. Plus or minus 1 plus, square root of 1 plus the cosine of 330 over 2. Good? Good? Okay, what is the cosine of 330 degrees? Square root of 3 over 2. All right? You get that from your special chart and special triangles in the unit circle, or from your special table chart thingy that we use. Yes. All right. So it is the square root of 3 over 2. And we've got these nasty complex fractions to deal with again. 1 plus square root of 3 over 2 over 2. How am I going to get rid of that complex fraction? Multiply top and bottom by 2, right? And when we multiply top and bottom by 2, that's going to give us 2 plus the square root of 3 over 4. Now, but there's still this pesky plus or minus thing in there. We have to pick. All right? And we're going to pick based on the original problem. The original problem, we're looking for the cosine of 165 degrees. What quadrant is 165 degrees in? It's in the second quadrant, and the cosine is negative there. So we're going to take the negative answer. All right? Cosine is negative in the second quadrant, and so we choose the negative sign. Complex radicals there. We have a radical inside of a radical. We're not going to fix that.
For this test, will you let us have like a filled out table or unit circle? Or
Yeah,
whatever?
you can use those tables on this test.
Do we have to simplify that
From the 1 plus the square root of 3 over 2 step?
No, from the 2 plus root 3 over 4.
Oh, with the change the 4 to a 2. I would prefer, but if you didn't, it certainly I wouldn't bust you for that.
Wait.
I mean, because it's a pretty complicated mess anyway. If you forgot, I would be okay with that. She's talking. The question was, would you have to change this 4 to 2, or could you just let the 4 ride through? And as long as you show it under the square root, it's okay to leave that. All right. Yeah, let's do one more. Find the exact value of the sine of 105 using a half angle identity. Okay? The sine of 105 degrees using a half angle identity. The identity is, all right, first of all, what half angle, what angle are we looking for here? What's 105 is half of 210. And that is a special angle, right? It's a 30-degree reference angle in the third quadrant. So I know my answer is going to be negative. The sine is negative in the third quadrant. All right, the identity is that one. Sine of x over 2 equals plus or minus square root of 1 minus cosine x all over 2. Yeah, we're going to have to find the cosine of x, or do we? What is x? 210, right? So when we make the substitution, we would have cosine of 210, and that's a special angle, so we don't need to figure it out.
Wait, you said the answer is negative, but sine of 105, isn't 105 in the second?
I'm sorry. Yeah, I don't know why I was going into the third quadrant there.
I think we saw
210. Yeah, I went with the 210. Yes, we are going to pick the positive. Well done, Ashton. That's going to give us, what is the cosine of 210 degrees? Cosine of 210 is negative square root of 3 over 2. Yeah, that's going to end up being plus there, because minus and negative. Multiply top and bottom by 2 again. Or actually technically multiplying by the square root of 2 here, because those things are under radicals, but we'll let that ride. We'll just pretend we're multiplying by 2 inside the radical. So that's going to, when you distribute that, that'll give you 2 plus the square root of 3 over 4. Right? Does everybody see that?
Were you talking about on the problem before this? It was supposed to be positive?
No, this one. This one. No, the problem before this was supposed to be negative. We had that correct. But I made a kind of a mental blunder. When I switched to 210, I changed there. But we're looking for the sine of 105 degrees. 105 is in the second quadrant, and so it's going to be positive because the sine is positive in the second quadrant. We pick the plus, and again you can simplify the bottom to be the square root of 4, which is 2, and that gives you that.
So wait, why was it positive?
Because 105 degrees, our original angle, is in the second quadrant. So we really know right off the bat that this answer has to be a positive quantity because 105 degrees is in the second quadrant.
Okay.
All right? I think there may be another example. This one kind of, just put your pencils down. You're not going to have time to take notes for this one. Just have a look at it. Find the exact value of the sine of x over 2. All right, sine of x over 2, we're using our formula that we just used. Sine of x over 2 is plus or minus 1 minus cosine x over 2. And they're telling us that the tangent of x is 3/4 and that x is in the third quadrant, right? Got it? X is in the third quadrant between 180 and 270, pi and 3 pi over 2. All right, so I've got to, in this case, we would have to draw the triangle. X is a third quadrant angle. All right, so draw your reference triangle in the third quadrant. They told us that the tangent is 3/4. That's the opposite over the adjacent. Both of these are going to be negative because they're left and down, so that'd be negative 3/4. And that's going to give us a hypotenuse value of 5. And now we're ready to make our substitution into our formula. Plus or minus 1 minus negative 4/5, multiply top and bottom by 5. We get 5 plus 4, square root of 9/10, plus or minus. Now in this case, y'all listen, this is tricky. X is a third quadrant angle. Where is x over 2 going to be? Think about it. Third quadrant goes from pi to, pi to 3 pi over 2, right? If that's where that is, then where's x over 2 going to be? Pi over 2 is less than x. It's less than 3 pi over 4. So x is between pi over 2 and 3/4 pi. What quadrant is that? That's the second quadrant. And that means our value is going to be positive 3 over the square root of 10. Okay, homework.
Did you say we could use like a unit system?
Yes, you can.
Why do you have halves of it?
Yeah.
Why not?
That's weird.
What's the homework?
Yeah, what is homework?
For apologetics, we're going to, you know.
There's your homework.
We don't go to, yeah, we stay in this building. We don't even have to go over there.
Y'all have a great day.
Meeting is